Hi everyone, this is Miss McConnell here. Mr. Huff and I made these videos earlier this morning and posted them, but unfortunately they have no audio. So thank you to one of your classmates that sent an email giving us a heads up. I'm going to attempt to remake the video with the same quality that we did earlier. It's always a little bit weird making a repeat, so bear with us. And also just a reminder that as you're working through this, you really should be working through the prompts on your own. So this is going to cover mainly number 1 and number 2, and we're also going to connect it to the work we did on number 3. And so what you see here is the graph of the sine function from negative pi to pi. And then you see the reflection that you created in class today. If you followed the same sequence, or in some classes we skipped right to 3, so might be your first time seeing it, but we created a reflection over the x equals y line, since that will give us the inverse. So what we have, and what we want to remind you of, is that the inverse sine of x, which is equivalent to arc sine of x, does not equal 1 over sine of x. In fact, 1 over sine of x is a new function, and it actually combines our concepts of rational functions and our concepts of trigonometric functions. So we will study this, but this is not the inverse sine of x. Inverse sine of x is the inverse function of sine of x. So in order to make the inverse sine of x a function, in other words, have the inverse function of f of x equal inverse sine of x, we need to restrict the domain of our sine function to be negative pi over 2 to pi over 2. One thing that we talked about was that this actually could be, we could select a different part of the domain, but conventionally, this is the part of the domain that sine of x is restricted to. In fact, your inverse sine of x in your calculator also assumes this domain restriction. And so, of course, that corresponds to this part of our inverse function. And then, of course, our range is still negative 1 to 1. So that's one of the reasons that this part of the domain is restricted, is because you still get all of those values between negative 1 to 1. Now, connecting back to our work on number 3, which we recommended watching that video first, you have the sine of x equals 0.3. And remember that our argument x is an angle, whereas the output is a ratio of side lengths. And so you want to make sure that you can connect that to the right triangle itself. We're trying to find the angle measure that creates those side lengths. But then you also need to consider that there might be other triangles in the entire rotation. And so when we refer back to our function, and we're looking at that value of 0.3, we can go ahead and estimate that and say, okay, well, we're looking for that x value on our original function where the output is 0.3, right? So then we're looking for an output of 0.3 in our original function, and we're saying, all right, these are the x values that do that. And the sine function is really nice for this kind of problem, because then you can see that as we continue, you'll see those values repeated. Now, if we're looking at the inverse sine, then notice that we're actually looking at this corresponding value and this corresponding value. So if we are looking for that ratio of 0.3, we're actually going to see this here. And so notice here how we restrict that domain, so we only have that one output value. And so when we have the inverse sine of 0.3, that inverse sine, that input of 0.3 will give us the output of the angle. and we determined that that angle had to be less than pi over 6 or less than 30 degrees because of the relationships that it had with, for reference, this 30-degree angle, or pi over 6 radians of 0.5. And so you can compare that to that inverse sine graph as well. Of course, everything with trigonometry, you need to compare to all of the different representations that we see. And so on the unit circle, that domain restriction from negative pi over 2 to pi over 2, we see that here. Not sure why I did that. So we see that rotation happening here. Remember that negative pi over 2 just means we are going in the opposite direction, and positive pi over 2 is the positive direction. So positive direction being counterclockwise and the negative direction being clockwise. Now for reference, here is cosine as well. And to make inverse cosine a function, we conventionally will restrict the domain of cosine of x between 0 and pi. And you'll notice that that gets that range of -1 to 1. And so that corresponds with this part of the unit circle. And then on the inverse, you can see that that corresponding part of the inverse is that section that I just highlighted in green. So you want to make that 0 to pi. Now consider how the cosine of x or inverse cosine of x will be different from the sine of x. You need to consider those corresponding side lengths. So now your task is to make sure that you can identify all of these connections. You need to look at number 3, and what we want you to do is we want you to engage in the same process for cosine of x equals 0.3, making those connections from this part, which is the part 1 of this video. And so you need to, after you watch this part, go ahead and connect cosine of x equals 0.3 to our cosine graphs. Mr. Huff and I discussed that we didn't want to cover it in the video because we've heard from several students that it's really just too tempting to just let those videos play. So you need to make sure that you personally engage with the task and try and find all of those beautiful connections that you can use with trigonometry that just allows you to move from one representation to another useful representation and to use them strategically. All right, thank you so much for watching. Please make sure you do the assignment and additional practice so that you can engage with all of these wonderful trigonometric concepts. And we will see you next time in class.